Welcome to my channel. This is CCNA Essentials. This channel aims to provide a comprehensive course on the most essential knowledge required for the CCNA certification. Today, I will be discussing subnetting in Part 1, which includes the concept of binary and the components of an IP address. I will guide you through the binary process first because it is closely related to the IP address and subnet, which are the main focus of the video. Binary is a number system used in computing and digital systems. It uses only two symbols, typically represented as 0 and 1. In contrast, the decimal system, base 10, that we commonly use in everyday life uses 10 symbols, 0 to 9. Binary is widely used in computers because digital systems can easily represent and manipulate two states, such as on/off or true/false, using binary digits. It serves as the foundation for all digital data processing and storage, including computer programming, arithmetic operations, and representing data in memory and storage devices. Let's move on to how to convert binary to decimal. For example, there is binary numbers below 11010010, and this sequence is marked from 0 to 7, from right to left. When there is a 1 in a specific position, it means that you need to calculate 2 raised to the power of that position. If there is a 0 in a position, you can skip it. Finally, sum up all the resulting numbers. As a result, the binary number 11010010 is converted to 210 in decimal form. Next, I will show you how to convert decimal to binary. There is a number below 210. Start by dividing the decimal number by 2 and write down the remainder. 210 divided by 2 equals 105 with a remainder of 0. Write down 0 as the rightmost bit. Divide the quotient from the previous step, 105, by 2 and write down the remainder. 105 divided by 2 equals 52 with a remainder of 1. Write down 1 to the left of the previous bit. Repeat the division process with the new quotient. 52 divided by 2 equals 26 with a remainder of 0. Write down 0 to the left of the previous bits. Continue this process until the quotient becomes 0. 26 divided by 2 equals 13 with a remainder of 0. 13 divided by 2 equals 6 with a remainder of 1.6 divided by 2 equals 3 with a remainder of 0. 3 divided by 2 equals 1 with a remainder of 1. 1 divided by 2 equals 0 with a remainder of 1. Write down the remainders from bottom to top. These will be the binary digits representing the decimal number. The binary representation of 210 is 11010010. Regarding IP address, to understand how subnets are divided, we need to understand the components associated with an IP address, which include the IP, subnet mask, network address, and host address. There is a device assigned an IP address, 192.168.12.5/24. 192.168.12.5 is IP address, and /24 is mask, prefix. The first 24 bits are reserved for the network portion, indicated by 1s in the subnet mask, while the last 8 bits are available for the host portion, represented by 0s in the subnet mask. An IP address, Internet Protocol Address, is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. It serves two main purposes: identifying the host or network interface and providing the location of the device in the network. A subnet mask, on the other hand, is a 32-bit number used to divide an IP address into network and host portions. It determines the range of IP addresses that belong to a particular network. The subnet mask contains a series of 1s followed by a series of 0s. The 1s in the mask identify the network portion, while the 0s represent the host portion. Network portion: the network portion of an IP address represents the identifier of the network to which a device belongs. It identifies the specific network or subnet within a larger network infrastructure. The network portion remains the same for all devices within the same network. Host portion: the host portion of an IP address represents the unique identifier assigned to a specific device within a network. It differentiates individual devices or hosts within the same network. The host portion can vary for different devices within the same network. Necessary formulas for subnetting. The calculation of the number of IPs in a network depends on the subnet mask, prefix 2 raised to the power of 32 mask, equals 2 raised to the power of number of host bits. For example, I have mask/25, so I have 128 IP addresses when applying the formula. That is the total number of IPs available in a network. The first and last IPs are known as the network address and broadcast address, respectively, and should not be assigned to devices. Therefore, the number of IPs that can be assigned to devices is 2 raised to the power of 32 mask, minus 2 is equal to 2 raised to the power of number of host bits, minus 2. When it comes to purpose of subnetting. Subnetting is the process of dividing a larger range of IPs into smaller subranges with fewer IPs. This is done in order to assign them to different devices within a company's departments, such as PCs, routers, and printers. It involves increasing the subnet mask. For example, if we have the network 192.168.1.0/24, it means we have 256 IPs in total. Therefore, the number of IPs that can be assigned to hosts would be 256 minus 2 is equal to 254 hosts. Formula to calculate the number of subnets when breaking down a subnet mask from the original prefix. To calculate the number of subnets, you can use the following formula: a number of subnets equals 2 raised to the power of subnet mask has been divided minus initial prefix. Example, for dividing from /24 to /25, the subnet mask has been divided by 1 bit, from /24 to /25. So, the number of subnets would be, the number of subnets is calculated using the formula a number of subnets equals 2 raised to the power of 25 minus 24, which simplifies to 2 raised to the power of 1, resulting in 2, so each subnet has 128 IPs and 126 IPs available to assign hosts. Similarly, for dividing from /24 to /26, the number of subnets is calculated using the formula a number of subnets equals 2 raised to the power of 26 minus 24, which simplifies to 2 raised to the power of 2, resulting in 4, so each subnet has 64 IPs and 62 IPs available to assign hosts. That's all about the basic knowledge of subnetting. Thanks for watching. If you found this video helpful, please give it a like and subscribe. Thank you.